In this question, we're asked to rank the following molecules in terms of their boiling point. The first thing you want to do is look for ionic compounds and metals. So in this case, we have a metal, calcium, and a nonmetal, bromide. So therefore, we have an ionic compound. Ionic compounds and metals will have substantially higher boiling points than covalent compounds. So we can go ahead and mark that as 1. We now want to compare covalent compounds. The first thing we want to do is look at the molar masses of the compounds. Things with substantially larger molar masses are going to have substantially larger boiling points because they have much stronger dispersion forces. So let's go ahead and look at the molar masses. Here we have 59.1 grams per mole. This is trimethylamine. This is isopropanol, rubbing alcohol, which is 60.1 grams per mole. I'm not exactly sure what this one is, but the molar mass is 142 grams per mole. So what you'll notice is these two, A and C, have roughly the same molar mass, but D has a massive molar mass. Note, we did not include CaBr2 because it's ionic, and ionic compounds and metal compounds have substantially higher boiling points, so we just want to compare A, C, and D after we already eliminate that one as number 1. So if we look at choice D, much higher molar mass, much higher dispersion forces, it's option 2. Finally, these have similar molar masses. So how are we going to compare their boiling points? Well, it's by intermolecular forces. For trimethylamine, the strongest intermolecular force is dipole-dipole, because we have nitrogen bonded to 3 carbons and it has a lone pair. So this is going to be polar. So it has dipole-dipole as its strongest intermolecular force. In the case of isopropanol, it has an O directly bonded to H. So its strongest intermolecular force is hydrogen bonding. Since this, with a similar molar mass, has a stronger intermolecular force, it's going to have a higher boiling point. You're going to heat it up more to separate those molecules apart. Here, as dipole-dipole, which is still stronger than just dispersion forces, but it's not as strong as hydrogen bonding, so it's going to be last, and it's going to take less energy to separate the molecules. Remember that boiling point is about separating one molecule from another. So in a liquid, let's say isopropanol molecules are relatively close together. If we add heat energy, we can get them to fly apart and separate and boil. This depends on the intermolecular forces. The stronger the intermolecular forces, the more energy you're going to have to add. Said another way, the higher the boiling point of the molecule.